Okay, we're going to look at some techniques for actually measuring Young's modulus. When we stretch wires, we see a much, usually we see a much less dramatic stretch than when we're stretching springs. So we're seeing very small extensions. So the difficulty is actually physically measuring very small extensions of wires. So there's a couple of techniques that you should know about. Okay, first of all, just to remind you what Young's modulus is. If we start with a length of wire L and then we apply a force per unit area, the stress, then it will stretch, and the change in length over the original length is called the strain. And what we do is we normally plot the stress against the strain, and we get a straight line, and then from the straight line stress divided by strain gives us Young's modulus, which has the symbol E. Okay, let's have a look at the first piece of apparatus. Okay, so what we're trying to do is to measure very small increments in the length of the wire. So we must use something called a vernier scale. Now, if you haven't watched the videos on using a vernier scale, please go back and look at those. Right, the setup is that we now have two wires side by side. The first wire is our control wire, and it is just kept taut with a weight at the bottom. And our second wire, the one that we're going to stretch, is alongside it. Now, the reason for having two wires is that if we have things like change of temperature, where the wire can expand a little bit, this will compensate. Having two wires will compensate, because this one will expand as well as this one with temperature. Okay, so what we're going to do is we're going to stretch this wire and see how much it's stretched compared with this wire, which we're not stretching. And we need to measure very small stretches, so in here we have a vernier scale to measure very small increases in length. And that's basically it. The other technique I will show, just a second. Okay, this is called the Searles Apparatus. It uses the same technique, so we have again two wires, and the first one is our our comparison wire, and this is the one that we're going to add weights to. And but in this case we're not using a vernier scale to measure the increase in length, but what we've got a little beam here that has got a spirit level, so basically you try and keep this horizontal. Now, as this wire, as you add weights, okay, this wire is going to stretch, so this beam is going to tilt, and to compensate for that you wind this micrometer here to lift up this little beam, okay, until it's level again. And what you can find from this is the amount that you wind up is basically the amount the wire has stretched. Now, the advantage of using this technique over the one with the vernier scale is that this is accurate to 1/100th of a millimeter, and the vernier scale is only accurate to 0.1 of a millimeter. So this is a more accurate technique. This diagram here is from Mr. Connolly's notes, so if you want to see some more details about this, have a look at those notes on his links. Okay.